Microservices are the future of scalable applications. But where do you start and how do you become job ready? If you are a Java developer looking forward to master microservices, then this video is for you. Hey guys, welcome to the session, the roadmap to microservices. If you are a Java developer or a backend engineer or someone looking forward to transition into microservices but doesn't know where to begin, then this video will get you a clear, structured learning path that will help you to become a job-ready microservices developer. Over the next few minutes, I will walk you through a step-by-step roadmap about what you need to learn in microservices, starting from the basics to the advanced concepts like what to learn in Kafka, Docker and Resilience 4J. This exact roadmap is what we follow in our hands-on microservices training program, where we build a real project in microservices from scratch. If you want to land in a high-paying microservices job, watch this video till the end as I will guide you through the core concepts, the tools that you need to learn and the best practices that are followed in many companies that are using microservices architecture. By the end of this video, you will have a clear, actionable roadmap that will help you to start your microservices learning journey easy. Stay tuned till the end. That will help you to start your microservices journey confidently. Now, let us get started. To start with, first you need to get an introduction about microservices. That is, what are microservices? What is the meaning of microservice architectural style? What are the key concepts or what are the features of microservices? As in, each microservice is self-contained, independent, it has its own database and few other features. So you need to know about the key concepts of microservices. What are the advantages of microservices? And what do the challenge that you will face if you are using microservice architectural style? The next one is, what is the difference between monolithic and microservice architectural style? You guys might be working in monolithic application. So when you are starting with microservices, automatically you will understand what is the difference between that and this. But still, you need to understand the key pointers which is making companies move towards microservice applications. The next one is, what are the key components of microservices? This becomes the core part of your microservice learning journey. If you know all these components of microservices, then you will really become a job-ready microservices developer. Rather than showing with the PPT, when we are discussing about the key components, I will explain it using a pictorial representation. Come back and I will cross-check whatever we have seen is correct or not through the slide. Next one is 12-factor app. Whenever you are creating a microservice application, you need to consider the 12-factor app. That is very important for developing microservice applications. And finally, you should know about the design patterns that are in microservice architectural style. Guys, you might be from Java background. You know what are all the different design patterns that are available in Java. As in singleton, prototype, factory, strategy, iterator. So many design patterns are there in Java which is used in the appropriate places. Similarly, microservices have its own set of design patterns which has to be used accordingly for working with microservices. So these are the fundamental topics that you need to know before moving into the key components of microservices. Next, build and register microservice. First is choose the right framework. My dear guys, we are working with Java. So the framework that we will be using is Spring Boot. If you want to learn microservices, there is a prerequisite. You should be comfortable working with Java and also you should know how to develop REST APIs using Spring Boot. Without that, jumping into microservices will be difficult and confusing. Next, build the microservice. Rather than seeing it from the slide, let me explain it using the pictorial representation. Once we have completed there, we will come back to the slide for cross-checking. My dear guys, whenever you want to learn microservices, it is only learn by doing. While coding, automatically you will understand the underlying concepts of microservices also. So to start with, let us create our microservice ecosystem. The first step is we need to build a microservice. Assume if I am working in an e-commerce application, the microservice that I am building over here is product catalog service. One single application is decomposed into multiple services. So I am having multiple services over here. You can build your microservices based on a particular design pattern. Here I have built the microservices based on the functionality. I have product catalog service, I have user service, cart service, order service. These are few microservices. The first thing that is needed is the microservices should register themselves to the service registry. So it is mandatory that you need to learn about service registry. The service registry that you are going to use can be Eureka or Console. In our case, we will be using Eureka. Eureka is open source. It is from Netflix OSs, so you can use it very easily. In our trainings, we use Eureka Service Registry. The microservices that you have created should register themselves to the service registry. This will be your first component. The microservice that you are building, as I told, is a REST API. It can also connect to the database. So I can have the product catalog microservice connected to the database. Each microservice has its own database, or it can share the database with other microservices. This also is kind of a design pattern. Now, let me go back to the slide. So we build the microservice. Our microservice may or may not be connected to the database. The database that you are using can be SQL or NoSQL database. Next, create the service registry. The service registry that you are going to use can be Eureka or Console or Zookeeper. Each microservice should register themselves to the service registry. Only then they will be visible for other services. Next, service communication. What exactly it is? Here I have got multiple microservices. Now the user service wants to connect to product catalog service to get the list of products, get one product by ID, get product by brand and so on. This means one service is trying to communicate to the other service. The communication can be synchronous communication or asynchronous communication. If it is a synchronous communication, you can use REST API, just like how you communicate between two REST APIs using REST template, or you can use gRPC, which is an open source framework, G remote procedure call, which also helps to communicate between microservices. Or there is one other way, we will discuss about that later. In case of asynchronous communication, it is message based. As in, we will use message brokers like RabbitMQ or Kafka. You all would have heard about Kafka. Kafka is an event-driven streaming API which helps to communicate between microservices. One best example is if you have ordered food, you are tracking your order. You just want to see where the delivery guy is. So to get the real-time tracking information, you can use message brokers like RabbitMQ or Kafka. Okay. So the next thing that you need to know is communication between microservices, service communication. Okay. Now let me go back to the slide again. Understanding service communication, whether to use REST or gRPC or messaging. Use REST for synchronous communication or FEAN client. What it is, we will discuss. Implementing asynchronous communication using Kafka or RabbitMQ. So this is about service communication, the next topic. Then config server. What is the purpose of a config server? Why should I use config server? How to work with config server in different environments? Let me explain it and then we will come back to the slide. In this case, these microservices are connected to the database. This means in your YAML file, you have provided the configuration details to connect to the database. That is the URL, the username, the password, the logging details and so on. Rather than writing all the configuration details in a YAML file, what you can do is you can add everything inside a Git repository. Meaning to say that the application.yaml for these microservices can be stored in the Git repository. But how do these microservices communicate to the Git repository? Can they communicate directly? Not at all. Rather, they can do it using a config server. Config server is a centralized server for managing the configuration details of multiple microservices. What exactly it is going to do? It will just have the details about the repository, that is the links to the repository. It's like a treasure hunt. Assume there are three people, A, B and me. I am having the original treasure. A wants to find the treasure. A cannot come to me directly. A will go to B. B will give a paper where the details about the treasure is available. As in, B will give the details about me. Through that, A will connect to me. Just like that, the config server will have the link of the repository. The repository will have the original configuration details. Now, these microservices will connect to the config server to get the details about the repository. That is the link of the repository. This way, we are avoiding mishaps. How? Suppose say, as of now I am using MySQL database. Suddenly I want to change the database to NoSQL database like Couchbase or MongoDB. What happens? In that scenario, in every YAML file I need to go and change it. Meaning to say that I need to redeploy my microservice. But if I am going to add those configuration details in a separate repository, it is enough I will modify the contents of the repository alone. The microservice will anyways come through the config server to get the link. You don't have to redeploy your application again. Okay. This config server also helps to manage the configuration details for different profiles like development profile, production profile or testing profile. Based on the profile, you can create the configuration details. So, the fourth component that you need to know is config server. Now, let me go back to the slide. So, you should understand what is config server. Why do we need centralized configuration? How does config server work in a microservice? How to create cloud config server? Connecting your cloud config server to the repository. How do you manage the configuration details in different environments? That is, for that we will be working with profiles. The next part is Gateway API. What exactly is Gateway API? Let us understand it first. Whenever a request comes from the outside world, from the external world, from a mobile application or from a React or Angular application or from a Spring or web application, from any kind of application, they cannot communicate to this microservice application directly. They have to pass through a gateway API. This gateway API is responsible for routing your request to the appropriate microservices or for doing logging or for taking care of authentication or for compressing the data. So, you need to be comfortable working with Gateway API. So, it is mandatory that you need to implement Gateway API in your microservice application. This is Gateway API. So, for that, the library that we will be using is Spring Cloud Gateway API. Let me go back to the slide. Understand what is API Gateway. How do you set up a Gateway API? How we will be using Spring Cloud Gateway API? Guys, here you can do it both programmatically using your Java code or declaratively using application.yaml. So you need to understand both the ways for routing your application from the front end, from the external world into your microservice ecosystem. Okay, path-based routing and service discovery. Load balancing with API gateway. This means the next component that you need to learn is load balancing. Let me go back. Load balancing. If you guys are working in Java development or Spring Boot application, you all know about load balancer. What is the purpose of load balancer? When the number of requests coming to a monolithic application is more, automatically the load balancer will reroute the request to a different server having the same application. Meaning to say that one single monolithic application will be deployed in multiple servers. If the number of requests coming to one server goes beyond the threshold, then automatically the request will be rerouted to another server. That is taken care by the load balancer. This is called as server-side load balancing. In the backend, the server is responsible for rerouting the request to the appropriate server that is having this application. In our case, we are having multiple microservices. So, Gateway API also can do load balancing. When you say that Gateway API is going to do the load balancing, then it is called as server-side load balancing. Means when the number of requests coming from the client goes beyond the threshold for a particular service, the Gateway API is responsible for routing it to a different server. What is the meaning of it? Here I am having only one service, right? So this means if I feel for a particular microservice, the number of requests will be more. For product catalog, I may get more requests because everybody wants to see what are all the products available, the products by brand, the products by category. In that case, I should run multiple instances of the same service. Just like how you deploy one application into multiple servers, here you deploy your product service in multiple servers. It means you are running multiple instances of the same service. You know Java, right? One class is there, you are creating one object. If you are creating multiple objects, it means multiple instances. Here you are running multiple instances of the same service. As in, this is running in port number 81, this in 82, this in 83. Each instance is running in different port numbers. Now, if it is server-side load balancing, if the Gateway API has to pick and choose a particular instance, it will select the instance based on load balancing. This is server-side load balancing. Similarly, you have client-side load balancing. In case of client-side load balancing, it is between microservices. Now the client decides which instance to pick and choose. For product catalog, user is a client. For product catalog, cart can be a client. So these two are clients for product catalog. Now they will pick and choose the appropriate instance based on their requirement. This means the client does the load balancing. This is called as client-side load balancing. If the Gateway API is doing the load balancing for an external client, for a third-party client, that is called as server-side load balancing. Okay, so this is the next component that you need to know. Together with that, you also should understand about declarative client. What we have seen is when we need to communicate between two microservices, we can use REST or gRPC. But now, instead of doing everything programmatically, declaratively you can use an API which is responsible for making an API call, provided you give the URL. Creating a REST API, creating the implementation class, communicating to the other microservice will be taken care by this declarative client. For this, we will be using Fiend. This is actually Open Fiend, which behaves like a HTTP client. So this is also important for you to understand in case of service communication. Next, let me go back to the slide. Handling failures and resilience. From now, we are moving on to the advanced concepts. Now that you have created your microservices, there are multiple microservices which are working together. There are scenarios where at a particular point of time, one microservice may be down. So it is mandatory that you need to handle those scenarios. Let me explain it with a basic example. Assume I have three microservices A, B and C. A communicating to B, B communicating to C. During a particular point, C stops functioning, meaning to say that C is connected to the database. Due to some issues in the database, the microservice C is not functioning. This means if a request comes from B microservice, C will throw the exception to B. B will throw the exception back to A. Now the exception will be thrown to the external client who is calling this microservice application, which is not a right way. If you are working in Java, how do you handle exceptions? You use try catch. If you are using Spring Boot, you will have a global exception handler which is responsible for handling the exceptions that is happening across multiple controllers. Similarly, if an exception occurs in a microservice, you should not allow the microservice to propagate. Rather, the next microservice should capture it and send a fallback message to the other microservices. The purpose of catch is to capture the exception and give a user-friendly error message. Similarly, here also the microservices has to behave in that manner. So for that, the library that we will be using is Resilience4j. It is an external library that is used for handling failures. It is not exactly exception. When I say failures, it means the microservice is down and it is throwing an exception saying that I am not available at this particular point of time. So that has to be handled. That is taken care by Resilience4j. Let me go back to the slide. Here in this case, you need to understand how to implement circuit breaker design pattern. What are the failover strategies and fallback responses? As I told, you need to send a user-friendly result to the calling microservice. Now, I want to know what are all the beans that are available in the application, the health check of this application, the metrics of this application, how much disk space each microservice is taking. So, if I need to know all that, I have to work with actuator. Actuator is responsible for providing health checks and metrics for your application. So you need to add actuator as a dependency and work with actuator also. Every company expects resilience patterns in microservices, so don't skip this. The next one is much more advanced, which is taken care in real-time microservice applications. Logging, monitoring your microservices and observability. Logging. If you want to log the details in each microservice, that can be taken care. It is mandatory that you need to add logging. Logging also can be done in Gateway API, as I already told you. Gateway API is responsible for logging, for authenticating, for routing and also for compressing the data that is coming inside. The next one is distributed tracing with Zipkin. Now in our case, we will be learning only about Zipkin. What is the purpose of it? When a request comes from the external application into your microservice ecosystem, it goes across different microservices from A to B, B to C, C to E, and again take the reverse path, come back and send the result to the external client. So if I want to know the tracing path starting from the entry point till it returns the response back to the client, I can do it with the help of a library called as Zipkin. Zipkin is used for distributed tracing. So, the next one that you need to know is distributed tracing using Zipkin, logging and monitoring your application. This is also an advanced concept of microservice. Let me go back to the slide. Debugging microservices can be very challenging. So it is mandatory that you need to add Zipkin as a dependency to your microservice so that you can trace the path of your microservice, how the request starts, where the request starts, and the complete flow till it returns the response back to the client. Monitoring API gateway with Prometheus and Grafana. This is for monitoring your real world microservice application. Okay. The next part is about asynchronous communication. Already we have discussed, whenever we want to do communication between microservices, it can be synchronous or asynchronous. Asynchronous communications are message based. So in this case, in our training also, we will be learning about Kafka. Suppose I am having two microservices, order microservice and notification microservice. How messaging happens between these microservices, we will be dealing with by learning Kafka. It is mandatory that you should know Kafka if you want to become a job ready microservices developer. It is a part and parcel of every interview question. Next part, containerizing your microservices. Till now what we have seen is, we are creating all the microservices. These microservices register themselves to the service registry, and by that way they are communicating between each other. But in a real-time scenario, rather than using a service registry, I can containerize all the microservices within a Docker environment. And now these microservices can communicate between each other within the Docker environment. It is not going to run externally, but they are going to run within the Docker environment. So this is also mandatory that you need to know, because not all the companies will be using service registry. They prefer to have their own in-house service registry developed by the in-house developers. If not, in certain places when I am doing training, we don't use service registry, rather we deploy all the microservices within the Docker environment and they communicate between each other within the Docker environment. The next level to that is, you deploy your microservices within Docker environment and they communicate using Kubernetes server. That is the next level advanced part. If you are interested to do that, that also is fine. So let me go back to the slide. So you can use Docker to containerize the microservices. You will be running the microservices within the Docker environment. You can use Docker Compose for this part, or you can use Kubernetes server for working with microservices. That actually is an advanced concept. If you are interested to do that, you can do that also as a roadmap to become a microservices developer. Usually in my training, I have not gone to that part, but of course I give an introduction to Kubernetes. Now let me go back. So I hope it is clear. What we have seen till now is, what are the topics that you need to learn starting from the basic to the advanced part. Start with the introduction of microservices. Then you need to learn how to build microservice application that is integrated with the database, how to register your microservice to service registry, how to do communication between microservices. Then what is the purpose of config server, which is very important. If you are developing a microservice application from scratch, it is mandatory that you need to include config server. What is the purpose of gateway API? How do you handle routing using gateway API programmatically and declaratively? What is the library that you will be using? In our case, we will be using Spring Cloud Gateway API. How to do load balancing? You need to learn how to do server-side load balancing and client-side load balancing. While working with microservices, we will be doing it. We will be running multiple instances of the same service. We will ask one other service to call this, and we will identify in which service running in that particular port number is getting called. As in, one time it will be 8081, another time it will be 8082, another time it will be 8083. Internally, they have their own algorithms like round robin fashion, fault tolerance, fast response. Based on that, it will pick the appropriate service instance for response. Next one is declarative client. Rather than me writing the URL using REST template to communicate to the other microservice, if we are using Fiend is responsible for doing that. The next one is fault tolerance using Resilience 4J. Earlier from Eureka we used Hystrix, it is in maintenance mode. Even for Gateway API we used Zool, that also is in maintenance mode. So you need to learn and understand Resilience 4J. how to use circuit breaker design pattern, which is very important. Okay. Next one is distributed tracing using Zipkin. If you want, you can also go through Elasticsearch, Logstash and Kibana. Then finally, Dockerizing your microservices. So these are the topics that you need to learn if you want to become a microservice developer. Remember, it is not enough that you create simple microservice and checking these concepts. You need to develop it as a proper project, as in an e-commerce application or a delivery app or a booking app. Whatever application you want, you pick and choose. Start working with the microservices. You need to add the appropriate concepts and the tools that are needed for developing your complete microservice project. Few companies are using these microservices like Amazon, Guild, PayPal, eBay. These companies use microservices which are developed and deployed in different languages. It is not that all the microservices are developed only using Spring Boot. Few are done using Node, few are done using different languages also. So I hope it is clear till this part. So what are the final thoughts? If you want to become a job ready microservice developer, these are the steps that you need to take. Start with the basics. Understand the architecture, build a simple service. Move to inter-service communication using REST API, Fiend, Kafka. Focus on resilience, that is handling exceptions. Observability using Zipkin. Deploy the microservices. These make your microservices production ready. Let me show you a pictorial representation also. This is how your microservice ecosystem looks like. Here it is using Netflix OSS. Few parts of Netflix OSS are outdated. They are in maintenance mode. This is the complete microservice ecosystem. Whatever you are seeing as web REST API, service 1, service 2, these are all microservices. Here you can see Ribbon. Ribbon is a client-side load balancer. Fiend, declarative client. If REST API wants to connect to service 1, it is done with the help of Fiend. Then there is Hystrix. Now we don't use Hystrix. Instead you can use Resilience 4J. So every microservice should have the appropriate components added. If you notice, in case of service 3 and service 4, we have not added it because they are all end services and they are not communicating to any other microservice. They are only going to provide data to other services. Okay, so I don't have to add any Fiend or Ribbon. Okay, next you can see that this is not needed because this is outdated. You need to authenticate your application using Spring Security. Of course, you would have learned it in Spring Boot itself. Then Cloud Config Server, the purpose of service registry, then Eureka dashboard. You will see the Eureka dashboard where you will be seeing all the microservices that are registered which are up and running. How many instances of each microservice is running. All those details you can get it from the Eureka service registry. And config server is connected to Git repository. We have the configuration files. And the database, you can use any type of database you want. Now this is your end application. Like I missed Zool. Zool also has to be a part of your microservice ecosystem. Let me add it. I missed this. Now these are the external clients which are trying to communicate to the microservice ecosystem through the API gateway. In our case, we don't have Zool. It is Spring Cloud Gateway API. I will show you the pictorial representation that I have created. Okay. So this is the gateway API. Guys, no Zool. This is the external client, the outside world. This is your microservice ecosystem. All the services are registered to Eureka Service Registry. Whenever each microservice wants to communicate to another microservice, they have to go to Eureka Registry, check if it is available. Through that, they will communicate to other services. And you can see multiple rounds are there, meaning to say that multiple instances of the same service are running. That is, in case of service 1, I am having 3 instances running in 3 different ports or 3 different processes. Service 4, 4 different processes. And the client cannot communicate to the microservice directly. They can communicate only through the gateway API. I hope this is clear. Okay guys, I believe I have given a clear and actionable roadmap that help you to start with your microservices journey confidently. This is a structured learning path. If you are serious about becoming a job-ready microservices developer, I invite you to join together with me in my 25 hours deep dive hands-on microservices training program. Join the WhatsApp group now that is given in the description to get all the details about this coaching program and the early bird offers. That's it. I hope this is helpful. Thank you.